Our next speaker is Mr. Matthew Deluca. We appreciate him being here this afternoon. He is going to give a presentation called Race Against the Machine, Rapid Exploit Development via LLMs. Thank you.
All right. Before we get started, this is my first talk, so wish me luck. So a little bit of the framework based on the title of the presentation. Mandiant says the time to exploit from 2018 to 2019 was 63 days. From then, it's gone down to 44 days, and now down to 32. Right now, the way we measure the time for an exploit to come from after the announcement of the actual exploit is about a month. We're measuring in months and weeks. And realistically, with the advent of AI and these LLMs, we're looking at minutes and hours till these exploits are developed. And that fundamentally changes how we have to understand and perceive and deal with these exploits as they come out. So, quick disclaimer, nothing I say or do is a reflection of my employer. All work contained within is solely my own. I do actually have a white paper on this upcoming, but is pending legal reviews. And for the same reasons, I can't go as far into technical details as I'd like. So, show of hands if you've heard of AI. Okay, good. I hope all of you have, unless you've been living under a rock. Really what we're specifically talking about here is LLMs. And LLMs are interesting because for the longest time, we relied on highly specialized models trained on particular data sets. And with these kind of large language models, now we have a generalized model that we can actually specifically tailor or train on content, and it is able to completely surpass those previously specialized models. Sorry, what was that? Okay. Good. Okay. So, completely lost my footing. All right. So again, LLMs are very interesting because they're broad models that can be applied to a very wide range of specific scenarios. And that's pretty crazy because the way they essentially work is by guessing the next word. And somehow a word guesser is able to understand and take and process that information. And then, of course, chief amongst them is GPT-4, which is kind of what we're going to be evaluating here today. And the reason why this matters is because these are smart. Maybe not as smart as an expert, but smarter than the average layman. And that can be dangerous within the context of cybersecurity because you're giving laymen powers more akin to what an expert in the field would be. And one of those powers is the ability to code. And it can code good enough, but the question here is, can you code working exploits? And how hard is it? When we think about things being easy, we think about Metasploit, just opening it up and being able to deliver a payload. Easy is relative. Something might be easy for a big APT, but imagine that kind of power in the hands of script kiddies, and then that power in layman's hands. And that's what we're really focusing on here. How something as innocuous as a CVE description can actually be used to fully build working malware without really any knowledge about what's going on. And these are things designed to protect our systems and being used for malicious purposes. The first thing you'll run into is with coding vulnerabilities and exploits on LLMs is that the first thing they'll say to you is, I'm sorry, I can't do that. I can't help you with that. And it literally says those exact words. So the question is, how do you get past this? Now, there's many different ways. It used to be that you could go to the OpenAI playground or use the API, and it would, the sensors were less. They still exist, but it wasn't as bad. Nowadays, they've tightened that up a bit more. There's also prompt injection techniques that you're able to use, but they're not necessarily the best. So the question is, how do you trick an AI? Well, the answer is you tell it the truth. Here you can see I'm telling it to play the role of a hired ethical hacker / red teamer, and it answers just fine. This still causes problems, though, within the context of delivering a full working payload. It'll still arrow out, and it'll still not give you a full working code. So what you have to do is actually present it with some sort of framework, a terms of engagement. And after giving it both a framework, a context for which it exists, and a framework for it to operate in, it actually works no problem. And one of the important things here to understand is if you take a step back, this is not only able to understand coding and programming, but it has a working framework where certain things are acceptable and unacceptable. And it shows some sort of approximation of understanding and theory of mind. And the greater context for this is today is the worst AI will ever be, and it will only ever get better. So a little bit talking about the actual research here. The CVE we're going to be evaluating this on is CVE 2022-42889, often just called text for shell. This was in a popular Apache vulnerability that resulted in remote code execution and caused a lot of long nights for some people. The reason why this is chosen was because it's the perfect confluence of circumstances. It was a big critical vulnerability. It was a critical vulnerability that came out after the training date for the model, so it would have no awareness or context of this. It's open source and had fairly good documentation. There's actually a pre-existing POC to compare the code that it develops to some sort of baseline. And the actual NIST CVE description is half decent. It's not devoid of context. And honestly, it was pretty easy to build in Docker relative to some of the other things. So talking a little bit about the methodology. There's two things to evaluate. One is the level of detail. And that means how much detail are you giving the large language model to understand and interpret? That level of detail essentially comes down to 3 points. One of them is seeing if you give it the CVE description and the full POC, can it come up with anything, right? That's just getting that baseline assessment of how well can it do when you practically tell it what to do. Then going down, you give it less detail. You take the CVE and you give it the documentation as well. So it has that understanding and framework, but also knows what that vulnerability is. And then taking it to the next step, you take it down to just that CVE. And if it is even humanly possible for with just the CVE to develop a full working exploit. And then the idea of iterations. An iteration is essentially how many cycles does it take for it to work and build a full working exploit with code. Each cycle is essentially a prompting. So the way it works is if it were to have some sort of error or no result, that information would be fed back, and that would be the start of the next iteration. So how many of these iterations, one by one by one, does it take? How long does it take? How easy is it? How hard is it? How feasible is it? It's important to understand that because the context we're looking at this is for someone who is not adept at anything related to coding, not adept at cybersecurity, someone with just a baseline knowledge. So giving it the both the CVE description and the full POC details, this was the first code it was able to come up. Now, you'll notice I'll point out a couple things, which is that it kind of lifted wholesale that JavaScript argument where it's adding 195 and 324, but it actually significantly slimmed down the original code into just this code block. Anyone want to guess if this will work? I have to give away a prize. Who says this will work? Who says it won't work? Won't? Won't? Well, let's see. It immediately works. Who said will? All right. Yeah, no, it immediately works because basically you're giving it just the POC information. That POC has some semblance of working code in it, and that working code is able to be translated, understood, and it's able to boil it down to those core concepts and actually condense it quite significantly. If you see the warning in some of the outputs, that's just incidental. But that's good. It's not, wow, that's amazing. You've literally gave it the code base and the understanding in order to do it. It worked, but it better have if anything else had a chance. So this is a brand new thread, new code, no previous understanding of the previous thread having what to do with the POC. So this is just giving it the information from the documentation and the CVE only. What I will note for this round of iterations with the documentation and CVE is that it gave a prompt at first that was just a guide of how to do it, but only word-based, and to prompt additionally for an actual code block. And interesting with this one, it didn't generate one script, it generated 3 separate scripts, basically going through the vulnerability and looking at what core components were vulnerable. Here it's testing printing. How many iterations do you think this took? Any guess? 3? Good guess. It instantly worked. That's fantastic. And a little bit scary. Now, there's 3 separate scripts, so we have to evaluate, do all of them work? So let's look at the next one. The next one is doing basically the same thing, except this is doing an example of DNS, essentially being able to run code querying for DNS. And much like the first one, it works first try. And that same story goes for when we actually evaluate for pulling a whole web page. So with only the description and the documentation of the software, it was able to build a full working exploit. Devoid of the context of any POC, devoid of any idea of what the code should properly look like, just that understanding that something's wrong based on that CVE, and having a working understanding of what the documentation for the software looks like, it was able to build this full working exploit. And it's in one shot. It's not even multiple iterations. We're not talking about going through and coming back and going through and coming back and fighting tooth and nail. Why would have taken longer to build this? This is really impressive. That being said, not all applications, all pieces of software are open source, and not all of them are honestly, they don't have great documentation. And that's something that I have dealt with a couple times, and it may seem like a security feature in this context, but I can promise you it's not. So that's where this comes in. Just the CVE description only. I would struggle to build full working exploits with just the CVE description only. I'm sure a lot of people would. Okay, how many iterations do you think it'll take for the next one? 1, 5. Any other guesses? I haven't heard it yet. 3, 4. So yeah, it takes 4 iterations to develop a full working POC code. Let's look at that step by step. So the first thing it did was output absolutely nothing. So typically the process is to just copy the error output back into the interpreter. Here, it was just told, it was prompted and said nothing outputs. So what's really interesting is that it changes it drastically. This is a much larger code block. You can see that it utilizes a lot of try catch it. It has some print statements. It tries really hard to put everything out there and just kind of throws everything at the wall. And another big point, and this is something from doing testing with this and trying to work with this exploit prior, it changed this whole string substitutor part at the very top. And that fix is the difference between it working and not working. It found that without really knowing any information. It changed that when really the only context it was given was, hey, nothing output. Still, that doesn't work. So what do? We take that output and we iterate it. The reason it doesn't work here is because it tried to invoke Java as opposed to JavaScript, actually. So here it does something extremely, extremely surprising, because I've worked with using LLMs for building code quite a bit. It cuts a lot of fat. This script is significantly shorter than the prior one. And it doesn't normally do this. So that was a very interesting finding. The question is, does it work? The answer is kind of. You can actually see that it does do the print statement correct. It does get the DNS correct, but it errors out at the last minute. And that's not what we're looking for. We're looking for full working exploit and vulnerability. Well, give it one more check. And here you can see it works all the way. Every single part, every single function, everything works. Now, we're talking the concept of 4 iterations. 4 iterations doesn't seem like it doesn't seem great when you compare to the 1 iteration and the 1 shot of the previous ones. But that's not bad at all. That's, what, 20 minutes? It took me longer to set up my Docker environment to run the testing than it did to generate malicious code. And that's pretty scary, because basically every new CVE that comes out, especially these critical ones, becomes some sort of 0-day with working POC code almost immediately. Though obviously you don't have to go back and test for it, but when it comes out, it essentially comes out with a POC code fully enabled. And that's very easy to utilize, and it's something that someone with very little knowledge could do. Now, carrying out the exploit is another issue. You actually have to deliver the payload, you have to do all that rest of the stuff. Well, that's pretty easy too. You ask it to put it in Metasploit. This is not all the code, but it not only does this work, it gives step-by-step instructions on how to make it work. So you're talking about, with just a CVE description and 30 minutes, you have a brand new exploit with zero knowledge that you can go deliver in that instance. It's so much more accessible. It's not something that my grandmother could do, but it's something that your average office worker who's disgruntled could spend a weekend doing, and it would take almost no skill. This essentially gives everyone access to working POC code very quickly. And especially for these large critical vulnerabilities, that's terrifying, because it's no longer these large APTs or even well-funded cyber criminal groups. It is everyone with access to working POCs within hours, minutes of when these CVEs drop. And there's a lot of implications to this. We can't measure time to exploit in months and weeks anymore. It's minutes and hours. And it's not just these big ABTs with these access to these POCs and what are practically 0 days right off the cuff. This is everyone. And it's something that we need to think about how we deal with. We need vendors to drop patches more often as soon as the CVE comes out. That's kind of a pipe dream sometimes, but hopefully this will put some pressure on them. And one of the kind of ironic things is that it might be better to have less descriptive CVEs, because those less descriptive CVEs give these threat actors, or just laymen, less information to work on. So that is more of a question posed to you, because that obviously comes with the trade-off of not having the information. But the point of the matter is that everything needs to be treated like there's working POC code out there. So based on that, here are some couple recommendations of like how to come to terms and deal with this. Obviously, more real-time monitoring defenses. This is more on the preventative side. This is stuff like SOAR. This is stuff like just having good agents on machines that are blocking things. This is all pretty standard stuff. Next, and you've heard it before, patch early, patch often. Make sure you patch as soon as possible. The problem is, though, that delta between when the CVE is released and the vendor drops the actual patch for the software. And you're just waiting in the open until that happens. And that focuses more on remediation. Then we look at focusing on infrastructure resiliency, essentially making sure that if you do get breached, you can maintain operations. And that has to do with more network segmentation and network isolation and system isolation. And that all feeds back to the concept of zero trust. But fundamentally, that is just remediation. It's not a matter of if you'll be hacked or breached, but when. So we have to think about this within broader context and think what this means within our increasingly interconnected cybersecurity world. It's not just script kiddies and APTs with this tremendous power. It's everyone. And you have to remember, today is the worst AI will ever be. It'll only get better. And normally you don't see it coming. There hasn't been many changes as of late, but those updates are happening behind the scenes. They're trickling in, which they'll eventually come in a major release update. But in the open source side, they're coming in and getting up to the capabilities of these larger language models that are closed source. And it means that a disgruntled employee could wreak havoc at a company without the need for permissions, access. They could have everything revoked, laptop taken away and everything, and still have the capability to breach and hack them. Then you have people who are miscreants on a different level. You have people who could be hacking into hospitals, medical devices, energy grid hacking. There was just a report dropped 3 days ago, I want to say, where over 100,000 ICS devices were just connected to the internet. And those create real incidents. I'm sure you all remember the Colonial Pipeline breach that caused mass panic, gas prices to spike. You're talking about giving normal people who might be a little upset a great power. So everything is just available at the touch of a keyboard. Cybersecurity weapons for everyone. But honestly, much of the scary stuff is not really here today, like the speculative stuff. And no one can really predict the future, at least of all if you're in security. But access to AIs of this power will likely be restricted with better censorship. And this is a ways away. But it's not. Here's stuff that I legitimately can't really show everything about. This is information regarding TCAS, Traffic Collision Avoidance System. This is how airplanes detect other airplanes. It's an older system, but it's still very much in use. Essentially, it lets an airplane know how far away another airplane is and whether it should go up or down. Pretty simple stuff. There's a QR code here with a link to the paper that this is actually based off of. Well, one of the problems with this is that if you read this paper, you'll find out you can spoof it really easily. What happens when you spoof an airplane? You make these radar systems think that there's an airplane right in front of you. Well, you can make a plane dramatically go up, dramatically go down. You can make an airplane, you could overwhelm towers and completely run down traffic at an airport. You could fly what looks like a series of aircraft over restricted airspace. Imagine what the response could be. If somehow you could take this information and actually use an AI to build something like this and have what looks like spoofed TCAS traffic flying over the White House, that would invoke a huge response. And it's not far away, it's here. I actually have a lot of familiarity with this space. This works. This isn't something that took me an hour. This is something that took me 30 minutes and that every person can have access to within minutes. That's the danger. That's the scary part about all this. And, you know, like I keep saying, today's the worst AI will ever be. It will only get better. Before we know it, these sort of things will be automated. And it's only a matter of time until it becomes more accessible. I'm not saying the power has to increase. It doesn't need to get smarter. It just needs to become more accessible. And I don't want to necessarily leave you on a sour note, but the biggest thing we need to do is push for fighting fire with fire, using AI to combat like our enterprise systems, but also using AI to make sure that AI isn't outputting anything malicious, to cross-reference and verify itself. And yeah, but the main concern is it will get worse before it gets better. These will become more accessible. These will become more powerful, and more people will have access to these. That's it.